Now, after the completion of the valence bond theory, let me say you, now the wave mechanics now came into being, because valence bond theory actually goes under the classical mechanics. Now the wave mechanics came into being. Wave mechanics you have already studied in atomic structure, that is the Schrodinger wave equation. Before that we have got the Heisenberg's, we have got the de Broglie's equation, and so many. Now this concept came into being now, that is after the, what you can say, the completion of the valence bond theory. So there are certain limitations of the valence bond theory. So what are the limitations? First we'll see, then after that I'll say you that what the wave mechanics says about it. Now, limitations of the valence bond theory is that the first question was raised in valence bond theory is that and electrons are of like charges. Alright, now when the two atoms are approaching, like hydrogen, they have got electrons in it, they are of like charges, so they should repel one another. Alright, electrons are of like charges. We know like charges repels and unlike charges attracts. So they should repel one another. They should repel. How then they undergo the bond formation? How the sharing of electrons takes place? How the sharing leads to the formation of the what you can say, the covalent bond, or formation of a molecule, a stable molecule rather, we can say that. Because the outermost shell contains electrons. Any two atoms, when they approach each other, it may be similar atoms or dissimilar atoms, they approach each other, they combine with one another and lead to the formation of the bond. But how it is? The electrons repel one another. So it's a, what you can say, a big question mark was put on the valence bond theory, that how it is possible. Alright, now the second question was that oxygen molecule was considered to be as a diamagnetic, because when oxygen atom combines with another oxygen atom, the outermost shell is fully filled, so it assumes a configuration of neon. Neon means it is fully filled, the outermost shell, we can say that. Clear? Oxygen shared with oxygen, isn't it? So hence its outermost shell is fully filled, because why it shares? It has got 6 electrons. So when it shares, the outermost shell has got now 8 electrons. It becomes stable. So that means it assumes the configuration of neon. That means it is diamagnetic in nature. But practically when we study the oxygen molecule, we see it is paramagnetic. That means it should have definitely unpaired electrons present in it. That means what it was explained about the oxygen molecule in valence bond theory, definitely it has got drawbacks. So this is another drawback of the valence bond theory, that it could not explain the nature of the molecule. We can say that correctly. For example, the oxygen molecule acid shape. Because when the share, then what happens? The sharing takes place. Oxygen has got 6 electrons in the outermost shell. It shares with another oxygen atom or another atom, and it becomes 8. 8 means its outermost shell is fully filled. That means it assumes a configuration of neon, let us say. Oxygen is in the same period with a neon. So neon means it is diamagnetic. But oxygen molecule is being seen. When oxygen atom combines to form a molecule, then oxygen is not diamagnetic. It is paramagnetic in nature. The difference between dia and para is that paramagnetic means it has got unpaired electrons present in it. I have said you in atomic structure, in spin quantum number. It has, due to the presence of at least one unpaired electron, at least one, it possesses some magnetic character. It possesses some magnetic moment. It has got some magnetic properties. But diamagnetic molecule, due to the absence of unpaired electrons, means all the electrons are as it is paired, it is completely, what you can say, unmagnetic. Its magnetic moment is 0, because magnetic moment is being cancelled, we can say that. It is being neutralized because all the electrons are paired, we can say that. Nothing is unpaired. If at least one is unpaired, then it retains some magnetism, but all are paired, so magnetic moment is cancelled. But it is not so. Actually, it is not so. Oxygen is paramagnetic. So this is another drawback. Now the third is that this theory does not consider the formation of odd electron molecules. How the odd electron pairs such is being formed, like H2 plus or He, what you can say, N2 plus or N2 minus. Alright, how does it form? Or why He2 molecule is not being formed? Now that was explained by the valence bond theory. The two atoms, when they approach each other, then the energy increases. The repulsive forces is more than the attractive forces, isn't it? So that concept is discarded. Alright, so now according to the new concept, according to the wave mechanics, then why He2 molecule is not being formed? We'll explain it. Alright. Now, why H2 plus is being formed, why H2 minus is being formed, or how it is being formed rather I should say. Instead of why, I should ask how it is being formed. how N2 plus is formed, N2 minus is being formed. Got it? Clear? Like peroxide ion, O2 2 minus, how it is being formed. Superoxide ion, O2 minus, how it is being formed. Got it? Clear? Now, it fails to explain the bonding in metals and non-intermetallic compounds. Metals and intermetallic compounds, it fails to explain how the bonding is taking place. Which one? Valence bond theory. Now, valence bond theory also fails to explain the bonding of electron deficient compounds. Electron deficient means in AlCl3. Electron deficient. It's a Lewis acid, I've said it. Like AlBr3. Then, what you can say, like FeCl3. Alright, this sort of compound, or BF3, boron trifluoride, or BCl3, boron trichloride. So these are the electron deficient compounds. Their outermost shell is not octate. You know that. I've explained you that particular thing. So it fails to explain that how this compound is being formed. Valence bond theory does not explain anything about it. Alright. So in this way, these are the limitations of the valence bond theory. For that purpose, the next theory we'll be studying is the molecular orbital theory. Always remember that one theory, why we should study, that you should understand first. That why we are studying this rule, why we are studying this theory, why we are studying this principle. If you understand that particular first, the limitations, if you understand it, then definitely it will be easy for you to understand that particular theory. So these are the limitations, that it could not explain the nature of the oxygen molecule. It could not explain how the formation of the bond takes place, because the valence bond theory says that the overlapping of the atomic orbitals is going to take place. But how it is possible? The electrons are going to repel one another when they come closer to each other. How it leads to the formation of a bond. And moreover, we can say that Heisenberg's uncertain principle says that we cannot define the position and the momentum simultaneously. Alright, listen carefully. Then how we can consider that the electrons are confined, alright, between the two combining atoms? How can we define them? When we cannot certainly say the position and the momentum, then how we can define the confinement of electrons between two combining atoms, isn't it? Between, like two atoms are combining. Here one electron will be there, another electron will be there of opposite spins. How can we say? When we cannot see the position and the momentum simultaneously, we cannot say. Heisenberg has already said. That means it goes against Heisenberg's uncertainty principle. We can say that. Clear? Electron theory, this particular theory, valence bond theory, also fails to explain the shape of the molecules, the different shape of the simple molecules. We are getting it from the VSEPR theory. I've said you earlier also. But the complex molecule, the shape, we do not know anything about it. Alright. So in this way, you can see for that particular purpose, the quantum theory, the quantum mechanics, we can say that it's not Planck's quantum theory. I'm saying. Alright. The quantum means that is quanta. Alright, clear, you can say that, clear. So that came into being, that is your Schrodinger's equation, Heisenberg's uncertainty principle, de Broglie's concept, it came into being for that particular purpose. So the advent of this quantum mechanics, or the advent of the modern atomic theory, we can say that, got it, now took place. It gave a death blow, we can say that, it gave a death blow to the valence bond theory, we can say that. So hence the new concept came into being, which is molecular orbital theory. Understood now? That these are the limitations of the valence bond theory, and also this wave mechanics, the molecular orbital theory also raised several questions regarding what you can say the this advent of this particular, or the regarding the truthfulness of this particular theory. Many questions was being raised. Alright, about this molecular orbital theory it raised. Alright, the wave mechanics is raised, and the new theory came into being by Hund and Mulliken. Hund and Mulliken. Who gave this theory? It was given by Hund and Mulliken in 1932. We can say that. So it is not so old, this particular theories. In 1932, Hund and Mulliken, they gave the postulates of this particular theory, of the molecular orbital theory. We can say that. Now, according to the molecular orbital theory, the atomic orbitals of the bonded atoms lose their identity when they form molecular orbitals. But valence bond theory, if you remember, it said that it does not lose their identity. But it says that it loses its identity. Means which particular atom loses identity? See, it does not mean that nitrogen combines to form oxygen molecules. No, that it does not say molecular orbital theory. The molecular orbital theory says that when nitrogen combines form nitrogen molecules, a nitrogen atom, what you can say, that is loses its identity. The atomic orbital loses its identity because it forms a new, what you can say, orbital, that is molecular orbital. Understand it properly. I don't say nitrogen becomes oxygen on combination. Two nitrogen will form oxygen or chlorine. No, I don't say at all that. That also has not been said by valence bond theory. Alright. That is, here the molecular orbital theory says that atomic orbital loses its identity and it forms a new orbital which is called as a stable orbital known as molecular orbital. So what are then the postulates given by the molecular orbital theory, or which is also called as MOT, we can say that. Molecular orbital theory, which was given by Hunt and Mulliken. I think you got it. Why do we require this particular theory? That's very important. Now, molecular orbitals, first of all, we see the definition of molecular orbitals. Molecular orbitals may be defined as the region in space in which an electron is most likely to be found. See, it is just a definition of orbital only. It is just the definition of atomic, what you can say, orbital. Orbital, what is an orbital? You have read it already. It's a region of three-dimensional space where the probability of finding an electron is maximum. Here also same thing is saying. Almost the same thing. Just the sentence is different. The language is different. Here it is saying that molecular orbitals may be defined as a region in space in which an electron is most likely to be found. Same thing it is. Now, this is the first point of the molecular orbital theory. The second point is that the wave function of an electron in a molecule is called molecular orbital. How do you represent a molecular orbital? We represent a molecular orbital by psi. This is a molecular orbital. This is known as psi MO. MO means molecular orbital. We can say that. We represent it in this way. The wave function, we have seen it. The wave function of an electron in a molecule is called as molecular orbital of an electron. For each electron, we have got different wave functions. Now, the molecular orbitals are obtained by combining atomic orbitals of comparable energies. Now, here you need to understand it. That any atomic orbital does not combine to give a molecular orbitals. When an atomic orbital combines to form molecular orbitals of comparable energies, it combines. Comparable means 2s and 2p is going to combine. 1s and 2s is not going to combine because they are of different energy level. 2s and 3s is not going to combine, different energy level. 2p and 3p is not going to combine, different energy level. So whenever they combine of comparable energies. Alright, that is atomic orbitals of comparable energies combines to form molecular orbital. Comparable, we can compare it. So this is comparable. 2s, 2p, 2p. Alright, 1s, 2s will not combine. 2p, 3p will not combine to give rise to a molecular orbital. That you understand it first from the beginning itself. Alright, so any atomic orbital does not combine to form any molecular orbital, we can say that. Alright, that also is being said in valence bond theory also. What you find is the atomic orbital, that is s and p will never combine. Px and py will never combine to give rise to a molecule. That also has been said in valence bond. It does not mean that valence bond theory is completely wrong. No, it cannot be, isn't it? So, now next is when a set of atomic orbitals combine to form molecular orbitals, the number of molecular orbitals formed is equal to the number of atomic orbitals which combines. Alright, when a set of atomic orbitals combine to form molecular orbitals, the number of molecular orbitals formed is equal to the number of atomic orbitals which is combining. So, how do we say this? See here. Like suppose we are having an atomic orbitals. We are having another atomic orbital. I am writing it as AO. AO means atomic orbital. Now it combines to form, you will read it in the next postulate, combines to form, that is nothing but molecular orbital. This is one molecular orbital it is being forming. And this is another molecular orbital it is being forming. Now you see the difference here, this difference and this difference. You see it, note it. It's not that according to my wish I have done it. Alright, it's not that according to my wish I have done it this. You can see that. See the difference here, clearly demarcated here and here you can see. If not, I will reduce this one further so that it will be much more convincing to you. Now it is much more convincing, we can say that. See the difference here. Alright, see the difference here, this difference and this difference. Why I said? Because what you find is that here, that is energy is much more lowered. Correct? Clear? So it is forming, or if you can do it in this way. Alright, let me tell you that also. Because in certain books you can find in this way, or in certain books you can find in this way also. Ultimately, I mean to say that the difference in the energy is not the same. That is what I want to say. In some books, one concept you have seen it. In some books it is written in this way also. This way also it is being seen in certain books. See this one, and this one I will take it below. Same thing it is, isn't it? Same thing. The difference you can see is the same. Alright, so there it was this one more, and now here this one is more. We can say that. So it gives rise. So now listen carefully. Understand it. These are the two atomic orbitals which contains 2 electrons. Maximum it can be. Orbitals always contains 2 electrons, not more than that. So it can have 1, but maximum 2 it is. So when it combines to form 2 molecular orbitals, this is 2 molecular orbitals. This is known as bonding molecular orbitals, bonding, and this is called as anti-bonding molecular orbitals, anti-bonding. Now bonding molecular orbitals, it is being formed, see, 2 plus 2, 4 electrons, so here 2 electrons will go and here 2 electrons will go. You will say, sir, if it is having total 2, let us say here 1 and here 1, then what will happen? Here 2 will go and here nothing will go, because it is being filled in the increasing order of energy. First the bonding will be filled, then the anti-bonding, because bonding is more stable than the anti-bonding. It is being filled in the increasing order of energy. Energy increases in this way energy increases. So if 2 electrons are there, one from here, then 2 will here will come. Correct? 2 here will come and here it will be vacant. Anti-bonding will be vacant. But suppose I am taking maximum 2, then here it will be 2 here and 2 here. But first this will be filled, then this. First bonding, then anti-bonding, because it is being filled always in the increasing order of energy. Who said? Aufbau's. So molecular orbitals theory is also in accordance with the Aufbau's principle, we can say that. See, it is taking the wave mechanics and it is moving forward. Molecular orbital theory. Still will come some more point also. It is taking, it is not that it is against. Alright, clear? Because this theory was born on the advent of wave mechanics only. So it is taking the Aufbau's principle, Hund's rule, everything is taking and it is moving forward. So first here 2 will be formed and here what you can say, nothing will be there if 1 is there. And if 2 is there, then you can 2 here, then 2 here. First it will be filled, bonding, then anti-bonding. This is more stable than this. And for that reason I have shown you also here. See, the energy is lowered more. Here if you consider the energy, the decrease in energy is more and the increase in energy is less. So if the decrease in energy is more, then the stability is more. So you can see it is more stable in nature. See here, see, the decrease in energy is more. It is losing energy more. When the 2 atoms, when the 2 electrons come closer, it is losing energy more. That concept is there, which is there in valence bond theory. So it is losing energy, and hence what you find is that it is forming bonding molecular orbital and anti-bonding molecular orbital in this way. It is being formed. One of the postulates it says that when atomic orbitals combines, it combines to form 2 molecular orbitals, that is bonding and anti-bonding. Bonding is having lower energy, anti-bonding is having higher energy. So the first the bonding will be occupied, then the anti-bonding will be occupied. So each orbital, how many electrons? 2 electrons first. Then if it is being left, the other orbital will be occupying. So the atomic orbitals combine to produce 2 molecular orbitals. One of the possess lower energy, then energy of the atomic orbitals. See, one of the possess lower energy, then energy of the atomic orbitals which is combining, and the other has higher energy than energy of the atomic orbital. See, comparing to the atomic orbital, this energy is higher. This energy is higher. You can see that it is increasing order, higher. Alright, the molecular orbitals with lower energy is called bonding molecular orbitals, alright, which is more stable, and the molecular orbitals with higher energy is called anti-bonding molecular orbital, which is less stable in nature. So this is more stable, this is less stable. Already I said you. Alright, first this, then this, always increasing order of energy. But the same question it remains in your mind, that how the combination is going to take place. That I will say in the next AV, that is LCAO method, linear combination of atomic orbitals. I said that atomic orbitals is defined by psi. Alright, it is defined by psi. The wave function of an electron in a molecule is molecular orbital. By the help of psi only, by the help of Schrodinger equation only, I will explain how the atomic orbitals combines to form molecular orbitals. I will explain it in the next. Thank you.